Welcome to the NJIT website and math podcast. My name is Vanessa, and today I will be covering proof of the Pythagorean Theorem. So, we all know what the Pythagorean Theorem is. It's the simple equation that a squared plus b squared equals c squared. And it all centers around the right triangle, where that a and b are the two sides that make up the right angle, and then c is what we call the hypotenuse, or the the side that brings them together. But how did we come to get this very simple equation that has pretty much revolutionized how we look at a lot of equations now in algebra and in calculus? And it's all actually based on right triangles. Several right triangles coming together based on bringing them together and making them into a square, and we're going to actually go over that concept in that proof. So we're going to go and dive right into that. So let's say we had a square. Okay. And this square, its sides were made up of two variables, a and b. So each side is composed of two segments, a and b, a, b, a, b, a, and b. Okay? So each side is composed of two segments that come together. And inside of this square is another square, which is its corners basically combine the intersection of a and b. So if you just connect these dots here, okay, it's not quite drawn to scale, but it pretty much, if you were to draw this exactly, it would just form another square. And these have all the same sides, and we're going to label them C. Okay, square 1 and square 2. Now, as you can see outside of that inner square, we also have 4 triangles on the inside. And it kind of looks like the right triangle of the Pythagorean theorem, where the sides are A, B, and C. So now what I'm going to do is I'm just going to label, first I'm just going to hatch these two triangles here. This one and this one. These two I'm just going to hatch them in so that they look different to the other triangles. They're the two triangles that we have. Okay, so here you can see 1, 2, and then we have the 3, 4 triangles. Okay, so now we're going to take all these shapes that are inside the square and we're going to rearrange them. So I want to draw the same big square over here. Okay, so all I'm going to do now is I'm going to take this triangle in here and then this hatched triangle here, and I'm going to bring them together to form kind of a rectangle. So if I do that, it's going to look something like this. Don't forget, because they both have a width A and another width B. So here's A, B, and B, right? And then one of these was the hatched one, which I guess I will hatch to be this one. Okay, so that was those two. And then we're going to do the same thing, but we're going to take the other two triangles, this one and this one, and we're going to draw them on the upper right corner, but flipped over. So we had side A, and here's the other side A. Here's side B, and of course they come together to form the two triangles, and then I'll make this bottom one the hatched one. Okay, so there we have those are the four triangles. And then because these B here, this side B and this side B, they form the square, that means that this side has to be length B and this side has to also be length B. And the same thing goes for this little square in the upper left corner. We have side A and side A, and because it forms a square, that means this has to be A and this has to be A. Okay, so here we have figure 1 and figure 2. Both big squares are the same size, and they're broken up into triangles, and then one big square in figure 1, and then all we did was take those exact shapes and reconfigure them and move them around to form figure 2. Okay, so then now what we're going to do is we're going to take the area of each figure by using the formula for square and the formula for the area of a triangle and combining them together. Okay, so let's look at figure 1, and we're going to write that on the left side here. Okay, if we go back, actually, okay, so we have the four triangles, as we said before, and they all actually have the same area, right? They're going to be 1/2 the length times the width, which is 1/2 A times B. And there's 4 of them, correct? So I'm going to write all 4 of them out. 1/2 AB plus 1/2 AB plus 1/2 AB plus 1/2 AB. Okay, those are the 4 triangles, and then if we go back, then all we have left is just the big square in the middle, which is the area of a square, which is just c squared. Correct? Okay, so that was for figure 1. And now let's condense this a little bit so that we have everything. So 1/2 AB plus 1/2 AB plus 1/2 AB plus 1/2 AB is just adding the 1/2s. So 1/2, there's 4 of them, so that comes out to be 2AB. And that's just combining these, and then plus c squared. Right? Okay. So that's figure 1. Now let's do the same thing for figure 2. To go back to figure 2, we have the same 4 squares. Same equations. The 1/2 AB plus the 1/2 AB plus 1/2 AB plus 1/2 AB. There's 4 of them. So again, it's the same thing. And I'm just going to rewrite it as 2AB because it was the exact same 4 triangles just moved around. The only difference now between figure 1 and figure 2 is the squares that were reconfigured. Okay, we have this first square here, which is a squared. So we're going to write that in. And then we have the other square here, which is b squared. Okay, so this is what was for figure 1, this was for figure 2. And now because they're technically the same object, or the same figure, but the inner shapes were moved around, they technically have to have the same area. So what we can take with these both equations is we can set them equal to each other. So let me do that in the next slide. So we have 2AB plus a squared plus b squared is equal to 2AB plus c squared. correct? Okay, so now all we do is, now we can notice we have 2ab and 2ab on both sides of the equation. So pretty much if we subtract 2ab on this side, we have to subtract 2ab on that side, which pretty much cancels them out. And what are we left with? A squared plus b squared is equal to c squared, which we all know is the Pythagorean Theorem. And that's the proof. So thank you for visiting the NJIT website. If you need any further assistance, please feel free to stop by the CAPE or the Center for Academic and Professional Enrichment, located in Kufrin Hall, room 200. Good luck in your studies.